Do you ever try talking to your friends underwater? If so, you have discovered that it did not work very well. Even though sound travels well in water, our vocal cord is not designed to generate underwater sound. So, how then can people communicate underwater? They use underwater wireless communication. In this past application, underwater wireless communication has been used to monitor coastal region for security, especially for military purpose. Commercially, underwater communication can also be used for investigation of natural resources in underwater environment, besides helping in mapping and discovering the unknown region of underwater. In terms of latest underwater wireless communication technology, they can also be used to detect environmental disasters such as tsunami by giving out early warning to citizens on land. My motivation for this work is to create an underwater communication system using radio wave for monitoring ocean environment and researching valuable seabed resource through an autonomous underwater vehicle. In underwater communication technology, there are three types of established methods that can be considered, which are acoustic, radio frequency, and optical signal. Therefore, a radio frequency signal will be used. Why I choose radio frequency? Radio frequency waves have higher data rates and faster signal propagation compared to acoustic wave. It also is unaffected by the water depth. How do we going to apply this in underwater wireless communication? There are several ways of employing such communication, but for my research I will design a microstrip mesh antenna to employ it. Before I explain the detail of my research, I will explain what is microstrip mesh antenna. A microstrip mesh antenna is a commonly printed circuit board antenna structure that is popular nowadays due to its advantage, such as small size, easily printed on any printed circuit board, and can operate at radio frequency. To make things clear, before starting my research, there is a thing that I need to consider, such as I need to determine the structure and dimension of the mesh antenna in seawater condition. Not only that, I also need to analyze the electrical properties of the mesh antenna, such as electric field distribution, near field distribution, meter loss, input impedance, and radiation pattern of the antenna in seawater condition, as it is varied by the change in salinity, temperature, and frequency of seawater. To solve this problem, for my research, I will do some series of calculations using a certain width and length of transmission line for the design and size of the mesh antenna. But this equation is not finalized. I'll be using an electromagnetic simulator named FECO to analyze the radiation pattern, input impedance, gain, electric fields, near field, and rate loss. Why I choose FECO? It is because FECO is the best option for the process of designing an antenna, as the software can be used for simulating our desired antenna in multiple environments including seawater conditions. The concept for the software is based on the integral formulation of Maxwell equation using method of moment (MOM). Optimization during early prototyping is also used to explore design possibilities where the internal geometry and ground plane are considered. The MOM solver produced very successful simulation in each step, allowing for many exploration of design. During the simulation, the mesh antenna will be simulated in the free space environment, then it will be tested in a seawater environment where the mesh antenna is designed to be enclosed in a clear case. The result from the free space will be compared with the one enclosed in the seawater environment. For my progress for my research, I will do more research through textbooks, articles, journal, and past thesis. From there, I will design the patch antenna using the electromagnetic simulator FECO. The result achieved will be compared and analyzed to determine its performance. That's all from me. Thank you.